Hi everyone, in this video I will show you how we'll compute and interpret an effect size under the two-sample t-test. Now the research question I've posed in previous videos is there a difference between mass and varied practice? But that's not actually the question we're after. The more interesting question is there a meaningful difference between mass and varied practice for learning how to throw beanbags into a bucket? We don't want to just know is one better than the other. We want to know if the difference is large enough to be meaningful. When we're testing the null hypothesis using a p-value, all we can conclude is that there is a difference. We can't say it's meaningful. Confidence intervals, on the other hand, can find a difference, and if you understand your scales, can determine if it's practically meaningful. But in some cases, especially in social science research, we may not understand our scales well enough in order to judge the practical significance using a confidence interval. And in that case, we might want to compute an effect size. For the two-sample t-test, or when we're comparing means, we're going to compute what's called a standardized mean difference, which I'm going to abbreviate SMD. Now, the standardized mean difference is computed by taking our statistic of interest, which is y bar 1 minus y bar 2, finding out how far it is from what we expect under the null, and now dividing by a standard deviation. Now, if you think about how z-scores or other ways of standardizing something, we're usually dividing by some type of standard deviation. In this case, because we're using the two-sample t-test, we're going to use the standard deviation based on the pooled variance. So we're going to take the square root of the pooled variance. Now, in most cases, the expected value of the difference in sample means is 0, so often we leave that off, and we simply divide the difference in the sample means by this pooled variance. So in this case, the mean for the first group was 25.38. The mean for the second group is 34.63. We expect that to be 0. And then we're going to divide by the square root of 43.84. That was the pooled variance. So this is a standard deviation, an estimate of the standard deviation of the dependent variable. And so this effect size ends up equaling negative 1.4. And you can see, first of all, it's negative because, again, just like a t-statistic, group 1 has a lower mean than group 2. If it was reversed, it would be a positive 1.4. We expect this effect size to be close to 0 when there's no difference between these groups. So the next question is, well, what is it? Is this large or not? And it's hard to interpret this number by itself without some type of benchmarks. And so there are some standard benchmarks we can use. So I'm going to take the absolute value of this standardized mean difference, so that even if it's negative, it comes out positive. And I'm going to provide some benchmarks for it. If this value is less than 0.2, we often consider either very small or maybe even trivial difference. If the difference is between, say, 0.2 to 0.5, it's small. If the standardized mean difference is 0.5 to 0.8, we consider that medium. And anything greater than or equal to 0.8, we often consider large. Now, these are initial benchmarks that you can use to judge the difference between two groups. However, it's important to note that these benchmarks could change based on the context of your study. So you may want to develop your own benchmarks given your field and what you are actually studying. Now, lastly, this standardized mean difference, when computed using a pooled variance, is referred to as Cohen's d. It was created by a famous statistician named Jacob Cohen, and he used in the denominator the pooled variance. There are other standardized mean differences, but not for the two-sample t-test is the primary one, but for other type of t-tests where you're comparing means, and they don't use the pooled variance under here.